allow you to use a format that you're used to and comfortable with to attack the problem. So we want to work on like our systems for how we solve these problems, because they'll help us be successful when we see problems we haven't seen before. They help us stay organized. And so the formatting of how we go about this stuff is just as important as getting to the answer. Okay? So first one we're going to solve here, we want to know how many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide, the amount exhaled by a person each day. Now, in this particular question, we already have our balanced chemical equation. They gave it to us right here. So we can start this problem. If we don't have a balanced chemical equation, we have to do that first. You have to write it first and balance it. Because if we don't have that, we don't know the mole ratio. And we can't do any of this stuff without having our mole ratio. That's the one thing that shows up in every single problem that we've done so far, is the mole ratio. And that comes directly from the balanced chemical equation. So that's what we need to do. All right, so with this one, we're going to start with our moles of given. They want us to do a mole-to-mole calculation. It says moles of given first. So we'll put this one in our notes. In this case, we have 20 moles of carbon dioxide. We're going to write down our moles of given. And then, based on our chart, or our map for how we solve these problems, the next thing that I need to put in there is my mole ratio. I'm already in moles, so I need to put in my mole ratio. So I'll go to my balanced chemical equation. I need the ratio between carbon dioxide and lithium hydroxide, which in this case is 1 to 2 or 2 to 1. Depends on how you want to approach that. Okay. I have carbon dioxide here, so carbon dioxide is going to go down here. In this case, it's 1 mole of carbon dioxide. My coefficient here is 1. Requires 2 moles of lithium hydroxide. Moles of carbon dioxide end up canceling out. That's good to go. I'm left with moles of lithium hydroxide, which is what I wanted. 20 times 2 divided by 1 is 40 moles lithium hydroxide, right? That one wasn't too bad. Pretty easy. Let's look at number 1 on your homework sheet. So now we're going to add some stuff so you have things to watch later, or look at later on. And ignore the directions about showing your work on another piece of paper. We're going to do everything on this one, so you can show your work, answer everything. Now, what's the one thing that's missing from problem number 1?
The balance.
The balance equation. So let's go. Let's start by writing the balanced chemical equation. Read the problem, see if you guys can figure out the balanced chemical equation that it's talking about, and write it down just above the prompt. Alright, when we read the question, it says ammonia is widely used as fertilizer, as an ingredient in many household cleaners. How many moles of ammonia are produced? So that means ammonia is our product. So we can write that down on the product side here. H3. Ammonia is our product. Are produced when 6 moles of hydrogen gas. That's what we're given. That's not part of the balanced chemical equation. When hydrogen gas reacts with nitrogen gas. So we have N2 plus H2. remembering that those are part of our Brickle-Phone elements, they're diatomic. Now we just need to balance it out. So put a 2 here, and a 3 here, and we're done. Hopefully, this reaction is getting to be familiar, because we've seen it on Pogel, we've seen it in a couple other places. This is a really common reaction, and it's used a lot because you have 3 different coefficients that you have to balance it with, so you have multiple mole ratios that you can create with it. Okay. So our given says 6 moles of hydrogen gas, so we're going to start by writing that down. 6 moles of hydrogen, sorry. And then our ratio, our mole ratio. And in this case, our ratio of hydrogen to ammonia is 3 to 2. Hydrogen is on the top, so it's got to go down on the bottom. 3 moles H2, 1 mole, 2 moles of NH3. 6 times 2 is 12, divided by 3 is 4. 4 moles of ammonia. Right, not too shabby, right? Let's do, I'm going to skip this one. We're going to go to number 3 on your problems. Okay. Just going to skip down one. Number 3 says when magnesium burns to air, it combines with oxygen to form magnesium oxide according to the following reaction. Hey, we already have our balanced equation, so we don't have to write it. You're going to skip to the good part. Solving the problem. What mass in grams of magnesium oxide is produced from 2 moles of magnesium? Really quickly, point to the starting place on your chart. Where are we starting at? They dug down with. Who else? Where are we starting? Yeah. Hey, if we don't, yeah, we're starting. There we go. Good job, Kelvin. We're starting in our. Did you look at Nate? Maybe. Okay, we're starting with our moles of given. Okay. And we know because it's giving us this value 2 moles of magnesium. So we identify our starting point. Now it's pretty easy to work forward, right? If we're given moles, our next thing that we're going to put there is our mole ratio. So we're given 2 moles of magnesium. Oh, man, try to get the numbers right. There are 2 moles of magnesium. The next thing we need to do is use our mole ratio. How are these things related to one another? Coefficients from our balanced chemical equation says that every 2 moles of magnesium produce 2 moles of magnesium oxide. So because those coefficients are the same, it's technically a 1-to-1 ratio, right? I'm going to put it in as 2 to 2. I don't want to screw up reducing a ratio. I don't want to screw up anything, so I just copy it down directly as it appears in the balanced chemical equation. Is it correct if you put 1-to-1? Yeah, absolutely. Or you can put 2 to 2. I prefer not to mess with doing like mental math. I just like to copy stuff down. So I would say 2 moles of magnesium and 2 moles of magnesium oxide. So my moles of magnesium cancel out. Now I'm in moles of magnesium oxide. The last thing I need to throw on here now is my molar mass. And that's the next step on my chart there. It says molar mass. And that's going to help get me into a mass of magnesium oxide, which is what the question asked for. So I have moles of magnesium oxide here, so I got to put moles of magnesium oxide here on the bottom. Now I will say one mistake that students sometimes make is they say, well, I put 2 moles up here, so I got to put 2 moles down here. Don't do that. Okay? This is a separate thing from this. This is my mole ratio. This is my molar mass. And whenever we use molar mass as a conversion factor, we write it in terms of 1 mole of substance. So I'm going to put 1 mole on the bottom here, and I need to put my molar mass on top. Oxygen has a mass of 16 grams per mole. Magnesium is 24.3 grams. Added together, 40.31. So now I need to make sure all my units cancel out and I'm left with my desired magnesium oxide. I've got grams of magnesium oxide is what they wanted. So now I just need to do a little math. 2 times 2 is 4 divided by 2 is 2 times 40.31. That gets me to 80.62. Now, how many significant digits do I get in my answer? Let's go through and count. We have to find the value with the least, ignoring our counting numbers. So this has 4. These 3 don't count because they're counting numbers. They have infinite significant digits. That one has 3, so I only get 3 in my answer. So my answer should be 80.6 grams of magnesium oxide.
I got it.
What do you mean by around?
The answer. I said I had 60.
80 flat would not be correct. Because you would have the right number of significant figures. So, Isaac asked a great question. He said, if I got the answer of 80, would I get that correct? Well, if you showed me your math and you had the setup correct, but you rounded to the wrong number of significant figures, like on a free response question on a test, you get 3 out of 4. Because you would have basically the answer, your units, and your setup, but you would be off on your significant figures, so you get 3 out of 4 points on that one. Okay. All right. Let's look at number 5. Just going to turn it over there. So this says oxygen was discovered by Joseph Priestley in 1774 when he heated mercury to oxide to decompose it to form its constituent elements. How many moles of mercury 2 oxide are needed to produce 125 grams of oxygen? First thing we got to do, write our balanced chemical equation. So let's start there. You guys go ahead and do that. It's a decomposition reaction. It tells us everything we need to know about this thing. Bless you. Bless you. So it goes 30 seconds first. So just get these ones. All right. So our balanced chemical equation should look something like that, which means we need to double the mercury and the mercury oxide to get it balanced. Okay.
Yeah, I just noticed that you're something that way. Did you?
Why what? So metals exist by themselves. Yeah, you just put some for it. Yep. All right. So in this case, we're starting with a mass. We're not at moles. So point to where we're starting on your chart. First step is to convert to moles using our molar mass. So you can see that conversion factor on your chart. So we have 125 grams of oxygen. In this case, the molar mass of oxygen gas is not 16.
32.
It's 32 because it's diatomic. We have 2 oxygens, each of them at 16 grams apiece. It's 32. So we'll put 32 grams right here. That's 1 mole of O2.
It's 32 because there's a 2.
Yep. 32. Okay. What's that?
Did you redo the ratio?
Now we do the mole ratio because we're in moles now.
2:1.
So we go to our balanced chemical equation. Every 1 mole of oxygen is produced from 2 moles of mercury oxide. So that's what we need to figure out here. So we'll put 1 mole of oxygen down here on the bottom because it was up here. And we put 2 moles of mercury oxide on the top. Go back through and check and make sure our units cancel out. Moles of oxygen go away, grams of oxygen go away. We're left with moles of mercury oxide, which is what we wanted. And now we just have to do a little math. 125 times 2 is 250, divided by 32 is
7.81.
7.81. And that's moles of mercury oxide. Let's add a 0 there, 32.07.
How many
What's that?
there's like B to that. Are we gonna do?
We're not gonna do B, but you guys can do B. Hey, here's the thing I'll say, there's a couple of questions that have B on them. B is a continuation of the prompt. It's separate from A, but you use the information in the prompt to solve B. Okay. Now, one last question that I want us to solve together, and then you guys will have hopefully about 5 to 10 minutes to look at some problems and start working on your own. Okay, we don't have a balanced chemical equation for this one, so we gotta get started. So we gotta write that equation first. Okay.
Latin, yes.
I think so. What type of reaction is this? Single replacement, good. Okay, so in this case, copper metal is going to replace silver in solution. We'll get a silver solid and dissolved copper ions. And to balance it out, we need to put a tube here and a tube here. And we're all balanced, right? Did you not get the formula for copper 2 nitrate, correct?
I forgot the oxygen.
Okay. All right. This is a mass problem. This is the longest type of problem that we'll have to work. So we can start with our given 100 grams of copper. And the first thing we need to do is use our molar mass to convert it into moles. So, 63.55 grams copper is our molar mass. And then the next step, mole ratio. We go to our balanced chemical equation. I know every 1 mole of copper produces 2 moles of silver. So at this point, I'm in moles of silver. But they want me to find the answer in terms of grams of silver. So I need to use my molar mass. 1 mole of silver is a mass of 107.8. 107.9, sorry. Okay, so then my moles of silver cancel out, and I'm left with grams of silver, which is what I wanted. So now I need to multiply 100 times 1 times 2 times 107.9 divided by 1 divided by 1 divided by 63.5. Carrie, you can do the math for us, buddy? Okay. So it should be 339.4.
But then you round it up.
339.5,
Yeah.
75.
0.4 something,
You're
right?
at 39.
I got
I got
5, 7.
575?
Yeah.
Now,
Just feel like
how many sig figs do I get my answer?
3.
100 has 3. So I get 1, 2, 3. This has got to be my last digit. So I looked at this thing around. There's something after my 5, so I go up, right, to 340. I got to put my decimal place there, letting me know that that 0 is not a placeholder, but it actually is significant. You get 340 grams of silver. Okay. In summary, first thing, write your balanced chemical equation. Second thing, find your moles of given. Sometimes that's easy because they already give it to you, right? Sometimes it's not. And you got to use your molar mass to convert. Then we're going to convert. Oh, geez, I skipped a step here. That's hilarious. Mole ratio. Convert to desired units. Wanted. Let's try that again. Write your balanced chemical equation. Find the moles given. Mole ratio. Convert to whatever units they want you to. If we look at this problem, this outlines it perfectly, okay? This gets me to moles of given, my molar mass. Here's my mole ratio. Converting between what I was given and what I want at the end. And then this is again my molar mass that allows me to convert into the units of what they wanted. What questions do you have? Starting with Carrie.
Well, I was thinking, so when it has like kilograms, are we supposed to convert to grams to do the?
Oh, you're looking at number 8?
Yeah.
You're gonna have to convert it to grams first to be able to do the molar mass, and then you convert it back into kilograms again. This time. Any other questions? No? Alright, we got a good 5 minutes that you guys can be working on the last 4 that you have for homework tonight. We're going to go over these at the beginning of the class period tomorrow. Okay? And then you have a chance for redemption. On the what? Test? You will not be able to use that on the test. You'll be able to use that on the quiz tomorrow. So that's like training wheels, right? We get comfortable with the method and then we take the training wheels off. Trust me, you can work with it. You can ride your bike so much faster without training wheels now. I mean, I just got mine off last week and I'm flying.
I know.
Well,